Okay, here's one of these other problems that it's probably not in my comfort zone. Haven't done one of these before, but I worked on it a while and I think I got it figured out. So let's take a look at it. It says the perimeter of the rectangle is 70 yards. So I'm just gonna write it in here just so that I know. So perimeter is 70. So the distance around the whole thing obviously is 70 yards. Tom starts at point A. Alright, so here's point A right here. In fact, let's not even call it A now. Let's just call it Tom. This is where he starts. Okay? And what's he do? He walks 50 yards counterclockwise. Remember, the distance around the whole thing is 70, so he doesn't quite go the whole way around. He goes 50 yards counterclockwise. Counterclockwise would be this way. This would be the opposite the clock goes. So let's kind of draw that in there. And we'll use different colors for this. So we'll use, I don't know, we'll use blue for Tom. And let's make it a little bit thicker. So I'm just going to do this by hand. So he walks, oh my goodness, maybe I'll use a line instead. Alright, so he walks this way, he walks this way, like that, and about like this, and I'm going to have him come just a little bit short, about right there. So we'll say that's Tom's distance that he went. Okay, so about right there. Let's fill that in. So we'll put him right there. So that's where he ends, at that dot right there. Okay, let's see what else. At the same time, Alice begins walking from a different point. It doesn't tell you where that point is, but a different point clockwise along the rectangle and continues until she has walked 40 yards. So let's do this. Let's write Tom. It's 50 yards, and then we'll do this other one, Alice. We'll do her in a different color. Let's do her in yellow. So we'll say Alice. We'll put her over here. Let's make that look a little more like a C. Alright, so Alice is 40 yards. So let's not do that just yet. The way around for Alice. Let's see. It says Tom and Alice end up 8 yards apart when they are done walking. Okay, so Alice is she's gonna walk 40 yards, and she's gonna be 8 yards from Tom. Now she's gonna go the other direction. So she's gonna be, if Tom and Alice end up 8 yards apart. So they're going to end up 8 yards apart. This is where Tom ended up. So Alice is going to end up 8 yards apart from her, and she goes in the counterclockwise or the clockwise direction. So I don't know. I'm just making a guess right here. Let's say that she starts here. Okay, so I'll just write in Alice. This is where she's going to start, and she goes 40 yards. And I don't know, let's say she'll go about right here. She'll end about right here. And she's going to go clockwise. So I'm going to do hers in yellow. So she's going to go about like this. Oh, wait a minute. That's not clockwise. What am I doing? This is clockwise. This would be a little better. Okay. So let's say she goes here, here, and here. Let's just drop that down just a little bit. There we go. And then she's going to end up right here. So I'll put a little arrow right there. And what's it say? It's about the 8-yard thing. It says if Tom and Alice end up 8 yards apart. So from here to here, from here, let's do this in a different color. Let's go this pinkish color. So from here to here is 8 yards. From there to there is 8. Alright. Remember, Alice goes 50 and Tom goes 50 and Alice goes 40. let's see, if Tom and Alice end up 8 yards apart when they're done walking, okay, I think we've got everything drawn in there. What's the greatest distance along the perimeter of the rectangle that could have separated them when they started walking? So we want to find that distance that separated when they started walking. So Alice started walking right here, Tom started walking right here. We want to find that distance, the greatest distance that separated them. Okay, so well, it could be along this way or it could be along this way. Let's just see what else we have going on. Again, I apologize if I didn't if I don't explain this the greatest. But let's see, it's 70 around the whole entire thing. So Tom ended up how far away from where he started? Well, he ended up 20 away. I think that's a key number right there. Because look, from here to here is 20. From here to here is 8. So what is it from this point to this point right here? That would be 12. It's not drawn to scale, but who cares? Alright, so from there to there is 12. And what are we trying to find? It says if Tom and Alice end up being, what's the greatest distance along the perimeter that could have separated them when they started walking? I had an explanation here. I know what numbers to put in, but let me think. From there to there is 12. So from where she ended up to where he started was 12 apart. So if I took her distance, okay, which is 40, and then look at this. Yeah, there we go. Watch this. If Alice's distance was 40, so that yellow all the way to her is 40. If we take away that 12, look what we have here. We've got this distance from here to here. That's the distance that separated them when they started walking. And so basically it's just 40 minus 12, which is 28. So 28 yards separated them from when they were walking. Let me just try to draw that in there. So this is where she started, and this, and down there at the bottom is where Tom started. So basically, let's just do this. And so that big old distance from there to there, that pink one, I don't know if you can see that very well or not. But anyway, that distance right there is the distance that separated them along the rectangle, along the perimeter of the rectangle when they first started. Now it might not be drawn to scale, but it should be pretty close. Anyway, I hope that makes sense. Hope I did it right. Anyway, I got the right answer, but because I know what the answer is, but there you go. So that is number 5, or sorry, number 18 on page 5. Alright, let's go to another video, and maybe I can put 3 from page 5. I'm sorry, we're going to continue. Let's just continue. Alright, I like this problem much better than I like the other one that we just did. It's a little bit more familiar. So let's just scooch this over here a little bit. Alright, let's see what they tell you here. It says that PQRS is a rectangle. It means you got 90-degree angles and all that kind of stuff. It says the area of triangle RST. Let's just jot that down. The area of triangle RST is equal to 7. Alright? And it also tells you something about PT and TS. T is not the midpoint of this, but it says that PT is 2/5 of PS. PT equals 2/5 of PS. Now this is the first thing that I did. When I saw that, I said, okay, this right here is 2/5. Now, the whole thing would be 5/5. It would be the whole entire thing. So TS would be 3/5 of that whole entire length. That's the first thing that I jotted down, and hopefully that helps a little bit. Now, what we have to do is we have to find the area of the rectangle. All right, so the area of a rectangle is just length times width, base times height, whatever you want to call it. I'll tell you what, let's call it base and height. Is that okay with base times height? They don't usually teach that when you're a kid, but they definitely relates to triangles and all that kind of stuff. So let's use base and height. So let's do this. Let's call this whole entire thing. Let's go different color here. Go green. So from here to here. And let's scooch these down a little bit. Get them out of the way. Alright, so let's call this whole thing right here because we don't know the actual the length of these things right here. So what I'm going to do is I'm going to call this the base of the whole rectangle, and I'll call this the height of the whole rectangle. Now remember, they told us something that was important that we're going to use here. It says the area of this triangle is 7. So what's the area of a triangle? Well, the area of a triangle is 1/2 the base times the height. Okay, so let's take a look, and we know the area though. We know it's 7, don't we? So we say 7 equals 1/2 the base, which would be 3/5. Watch this. It'd be 3/5 of the base times the height. We don't know the height. Right? So this is a little bit weird. We don't actually find the actual height, or we don't really find the actual base. Not at first, anyway. And you don't really even have to throughout the whole entire problem. But look, this is how I wrote this down. So area is, I'm talking about this triangle right here. Okay, this triangle right here, the area is 7, and it's 1/2 the base times the height. What is the base? Well, it's not just 3/5. It's not just a number. It's 3/5 of the base of the rectangle. All right, so I write 3/5 times the base times what? Times the height. Now the height of the rectangle is the same as the height of that triangle right here. Remember, this is a right triangle, so they are perpendicular to each other. So what I'm going to do is this. Remember what I want to try to do. I want to find the area of the whole entire rectangle, which would be the base times the height. So if you look at this, look, it's a little bit of a trick. I've got base and height right here, so let's actually get base and height by itself, not the base times itself, not the height by itself, but the BH by itself. So let's get rid of the 1/2 and the 3/5. So watch what happens. What's 1/2 times 3/5? That would be what? 3/10. Okay, BH. And again, what am I trying to do? I want to find what BH is equal to. If I can find BH, then I've got the entire area of the rectangle, because the base times the height is the area of the rectangle. So I use the triangle that they give us, put some numbers in. Now watch. How do I get rid of 3/10? Multiply it by the reciprocal. Multiply it by 10/3. So I come over here, multiply that by 10/3, put that over 1. So what does BH equal to? It equals 70/3. Well, I didn't really find the actual base or the actual height, but I did find what the base times the height was equal to. And that's what I was trying to find in the first place. I was trying to find the area of the rectangle, which is the base times the height. So there you go. I just found it. Without actually finding specifically the base or the height, I found the base times the height is 70/3, and I believe that's the answer. Okay. Yep, just keep it like that. You could put it into a calculator. 23.3, I believe, is the approximation. Okay, but I would just keep it 70/3. And there you go. That was a free response question, I guess, because there was no multiple choice on that one. So I would just keep it 70/3. That's an exact answer. Just keep it just like that. All right, that wasn't so bad once you figured out that little trick to get the base and the height by itself. Okay, combined by itself. Alright, this is the last one on this video. It says in the XY plane a circle has center at 0, 0, so that means that's the origin right there, 0, 0. And AB is the diameter of the circle. That's pretty self-explanatory, I think. It says, what's the equation of the line that passes through A and B? So what's the equation of a line that goes through A and B? Well, I would think that they, yeah, if you look at the, they give you, this is multiple choice, so they give you 5 choices, and they're all in the form y equals mx plus b. All right, so we want to find the equation of this line. Now look what they give you. They give you this point, which is 4k, which means you've gone over 4, so that's 4 right here. Look what they give you over here. You've gone over and down to -6, so this right there would be -6. Okay, so that kind of gives you some ideas here. What are we trying to find? Well, the y-intercept's easy. The y-intercept is 0. It crosses the origin, so the y-intercept is 0. So if you look at your choices, actually none of the choices even have a y-intercept, so that doesn't really help you out at all. What we're trying to do is we're trying to find the slope. So if we can find the slope of this line, then we should be good to go. So let's figure out how to do that. Well, let's look at this. We went over 4 and you went up. Now watch. This is the same distance because this is a radius of the circle. So from the origin to B is the same distance as it is from the origin down to A. So if I went over, if I start at the origin, depending on how many I go over, if I go up to get to that same point down here, I'm going to go over and down the same amount. So that's one thing to think about. Now watch. This went down 6, so if this is the same exact distance, this has to go up 6. So that point right there would be 6. So really, this point is 4. Oops, sorry. Write that a little bit neater. So this point would be 4, 6. That point right there. Again, because this is part of a circle. Right? If that circle wasn't there and you didn't know that this distance was the same as this, you wouldn't be able to do it. All right, but you do know it's a circle, so the distances are the same. So that point on the circle, over and up, is the same as over and down this way. So what did we do? We went -4 in this direction, so this is going to be -4, -6, this point down here. So once I know the 2 points, I can find the slope, and that's pretty easy. Let's do that. You could just count if you wanted to, but let's just do the slope formula. Slope is change in y over change in x, or you subtract the y, so 6 minus -6, which is the same as 6 plus 6, and then you go 4 minus -4, which is 4 minus -4, which is the same as 4 plus 4. That would be 12 over 8. 4 goes into those 3 and 2 times, and it's positive, right? So you know it's positive 3 over 2. So that's actually not the answer. I shouldn't have circled it. Let's not circle it. It says what is the equation of the line. So it's y equals 3/2 x plus 0, because your y-intercept is 0, and that would be the equation of the line, and that is letter C among your 4 choices.